Okay, let us talk about geometric progressions in this video. All these problems are from chapter 5A, which is about geometric progression from the book Hall and Knight Higher Algebra. So, because all these 10 problems are same, which is about summing the geometric progressions, so I have just made it into one video. So, let us first talk about what are geometric progressions. Okay, so geometric progressions are, for example, if your sequence is S is equal to, first term is A, then second term is A times R, third term is A times R square, then the fourth term is A times R cube, and similarly the nth term is AR n to the power minus 1. This sequence is said to be in geometric progression. What is happening is that each term is actually R times the previous term. Okay, so R is the common ratio, okay, and A is the first term. Okay, and nth term is A times R to the power n minus 1. Now, suppose we want to add this geometric progression. Okay, let us say that our sum is equal to A plus AR plus AR square plus n minus 1th term would be AR n minus 2 and nth term would be AR n minus 1. Suppose I want to add this. How can I find the sum of this series? I can multiply S by R. So, this becomes R times S. Now, A times R will become AR. So, I can write it here. AR times R will become AR square. So, this I will write below this, and similarly the n minus 1th term would be multiplied by R. So, that will become n minus 1th term will become AR n minus 1, n minus 2nd term will become AR n minus 2, and nth term will become AR n, right, because all that is happening is I am just multiplying R to each of these terms and I am just shifting it so that they are below their same corresponding terms in the above sequence. Now, if I subtract S minus RS, I get 1 minus R times S is equal to A. Now, this is minus, this is minus, each of these terms is now minus. Okay. So, AR minus AR cancels out, this cancels out, all the terms cancel out except the last nth term, which is minus AR n, or from this you can write that S is equal to A 1 minus R to the power n upon 1 minus R. So, this is the formula that we get for summing up the geometric sequence. This is how we can sum the n terms of geometric sequence, and this is the formula that we are going to use in each of the exercise that we saw before. So, for example, let us solve the problem number 1. Now, problem number 1 is A is equal to, what is the first term in problem number 1? It is 1 by 2. What is R over here? You can take any of the two consecutive terms and just divide it to find the R. So, for example, I can take 2 by 9 divided by 1 by 3. So, R is going to be 2 by 9 divided by 1 by 3. This will be equal to 2 by 9 times 3 or 2 by 3, right. So, R is going to be 2 by 3. So, now let us find the sum. Sum is going to be A, which is half, 1 minus R, which is 2 by 3. Now, 2 by 3 has to be raised to power 7 because we have to find 7 terms divided by 1 minus R, 1 minus 2 by 3. So, you can use a calculator at this stage to find the sum, but let me do this one by hand. So, this is 1 minus 2 to the power 7 is going to be 128, and 3 to the power 7 is going to be 3 to the power 5 is 243. 243 times 9, let me see, 243 times 9 is 9 times 3 is 27, 9 5 so 36 and 38. 3, 9 times 2 is 18, 18 and 3 is 21. So, it is 2187, and 1 minus 2 by 3 will be 1 by 3. So, if you simplify this, it becomes 2187 minus 128. So, 9 5 0 2. So, this is 3 by 2 times 2059 by 2187. This we know will be 3 times 7, 2, so this will be 729, and you can simplify it further if you can. So, this is 5 to 7, 9 and 7 is, so I think we will just leave this answer like this, but you get the idea, right. 2059 by 2 times 9 is 18, 58. So, 2059 by 1458. So, this is the answer that I got. I may have made some mistakes, but all you have to notice in this, do in this problem is just apply the formula and you will be done. And this is what you have to do for all of these 10 problems here, right.